Hey all! So today we're looking at operations of rational and irrational numbers. So first we need to go through a review of rational versus irrational. What's the difference? Now remember, rational and irrational numbers, they make up our real number system. So when we're looking at operations, we want to know if I perform operation, i.e. addition, subtraction, multiplication, division, if I perform one of those, what is the outcome going to be? Is that number going to be rational, irrational? Can it be both? So first, let's review rational and irrational numbers. Now, rational number. The most basic definition of a rational number is any number that can be written as a fraction. So rational is fractional. That's how I remember it. Rational is fractional. Now, irrational numbers. Those are any non-terminating non-terminating, so a number that doesn't end, or non-repeating decimals. Because repeating decimals can be written as fractions. If you don't remember how, I can do a short tutorial on that at the end of the video if you want to know how. So rational versus irrational. Rational is fractional, any number that can be written as a fraction. So let's go ahead and place these. Let me separate that. Okay, so rational numbers. Let's look around for some rational numbers. 0. 0 is a rational number. Now, can 0 be written as a fraction? Well, technically, sure, because I can put 0 over 1. Still 0, right? So, 0 is a rational number. How about 2? Can that be written as a fraction? Same deal. 2 over 1. Perfect. All right, 4.5 or 4 and 5/10. Well, if I read it properly, 4 and 5/10, I believe I have just created that fraction. So you can go ahead and make that a complex number if you wanted to. All right, now square root of 8. Square root of 8. Can we break that down? Square root of 8. Let's think about that. Is the square root of 8 a perfect square? Okay, remember, a perfect square meaning two numbers that multiply by themselves to get that. So let's go over to square root of 4. Well, what is the square root of 4? It's 2. So you always think about simplifying before you try and classify. So square root of 4 is 2, and again, we just said 2 is a rational number. Now, if you come back to square root of 8, square root of 8 is not a perfect square, which means if you were to put that in your calculator, you are going to get an ugly decimal. It's not going to have a pattern, and it's not going to end. So square root of 8 is an example of an irrational number. Negative 1/3. That's automatically a fraction. So yes, that goes into the rational category. All right, negative 5. Same thing, negative 5. I can put it over 1, create that fraction. 3.57 repeating. Now again, because that is a repeating decimal, I could write that 3 and 57 over 99 if I wanted to write that as a fraction, because it's to the 100th place. All right, so we don't have many examples of irrational numbers, so let's go ahead and think of some others. A very common irrational number that we use a lot, pi. Pi is an irrational number. It is non-repeating. It has no pattern. Non-repeating, so it doesn't have a pattern, and it does not end. Goes on forever and ever. Let's see. What's another one? Now, we also have some goofy ones like I and E, which we won't get into yet. So you can wait till Algebra 2, and you get to play with those a lot. So any square root that does not a perfect square is going to be irrational an irrational number. So even if we have a rational number in front of it, like 2 root 3, 2 is rational, yes, so that means 2 times the square root of 3, but if we're multiplying it by something ugly like square root of 3, that's still going to give us an ugly decimal that we cannot write as a fraction. So those are a few extra examples of irrational numbers. All right, so let's play this little game, sometimes, always, or never. So we're given the following statements, and we want to determine, are they sometimes true, always true, or never true? So I need an example to really wrap my mind around it. So when it asks me, the sum of a rational number and a rational number is rational. So let me think. A rational number, 1/2. So sum, so plus another rational number, let's take 5. Is that always going to give me a rational number? So if I'm adding two nice fractions, or what potentially could be nice fractions, will I end up with a fraction? Absolutely. I will always end up with a fraction. It may get a little bit uglier, like I might have to mess around and make those common denominators, that denominator might get a little larger, but it's definitely still going to be a fraction. So rational plus rational, always going to be rational. Now, let's think about the sum, all right, of a rational number and an irrational number. So rational number, so a nice pretty number. So again, we can think of 1/2, 7, 7/2 if we don't want it to be as pretty. So what if we add a rational number to an irrational number? So think about this, 7/2, 3.5. If I add that decimal to an ugly decimal, is there any way that decimal is going to end up being pretty enough to write it as a fraction? No. If I add this to pi, I'm still going to have that crazy long decimal at the end that doesn't have a pattern. So that is always going to be irrational. I don't see any way that we can make that rational. All right, so sum again. The sum of an irrational number and an irrational number. Okay, so pi plus pi. Crazy long decimal plus crazy long decimal. Is that going to end up magically being not a crazy long decimal that's non-repeating or non-terminating? Nope. If I have something that doesn't have a pattern and I add something else that doesn't have a pattern, it's going to continue to not have a pattern. So that's going to be irrational. Let's see. What about square root of 5 plus square root of 5? Well, that's technically 1 square root of 5 plus 1 square root of 5. So that's going to give us 2 square roots of 5. Again, that square root of 5 is still irrational. So this is always going to be true. Geez, I hope something changes soon. All right, product. So now we're talking about multiplication. So the product of a rational number, all right, 1/2, and another rational number is rational. Let's see. 1/2 times, let's find something that's not so pretty. Oh, what if we had one of those repeating decimals? Like 3.6 repeating. Well, I could rewrite that 1/2 times 3 6/9 because it's in the tenths place. So that would be 9 times 3, 27, 33. So 1/2 times 33/9. Is this going to continue to be rational? Yeah. It's going to be a little bit uglier. And yes, we totally could have simplified that. And we can simplify 33/18. But my goal is it rational? So I took a nice rational number and then I try to think of a funky rational number. The only real funky one is those repeating decimals. But again, they can be written as fractions, so we're going to end up with a fraction. A little bit messier, but still. All right, we got another always. Something's got to change eventually. I hope I didn't just pick all examples that are always. So, product of a rational number and an irrational number is irrational. So again, something pretty times something funky. Is it always going to be funky? Yeah, I think it is. Oh my gosh, I picked another always. I was not very good at picking my example. All right, so the product of an irrational number and an irrational number. Thank heavens, something that's different. So an irrational number. So let's see. Pi times pi. What is that? Pi squared, technically? So you've got that ugly, ugly number and you're multiplying it. So I'm just focusing on those decimals. Is there any way that those crazy decimals that last forever and ever are going to magically stop lasting forever and ever? No, that's definitely going to still be irrational. Now don't just stop at your first example, because another one is an irrational number times an irrational number. There's a special case. If we take an irrational number, so let's say the square root of 7, okay? If you multiply it by itself, that's going to give you the square root of 7 times 7 is 49. What's the square root of 49? 7. Is 7 irrational? Absolutely not. So, irrational, but this one, we're ending up with something rational. So finally, we have something that's not always. This is definitely a sometimes. All right, well, I hope that works for you guys. Hope that answers some questions. Don't necessarily stop with your first example because, again, you might end up with something different that gives you, a different type of outcome. So think about, is it always, sometimes, or never true? So, all right, well, I hope that helped. Have a great one.